All right, guys, today we're going to talk about converting decimals and fractions. Yesterday we did decimals and percents, and this is actually a little bit easier than what we did yesterday. Some of the steps take a little longer, though. So I'm going to put your name and your date at the top. When we're starting off, the thing you should know already, because we have talked about it before, is that the fraction is a division problem. And when you solve it, you get a decimal. So I shouldn't even have to go over this part because we have done it before. That's why there's not a lot of notes. So let's take a look at it. We're talking about turning a fraction into a decimal. So I'm starting with a fraction. I'm turning it into a decimal. All I'm doing is treating it like the division problem that it is. So a lot of you guys are going to want to say 4 divided by 20, that's 5. That is not right. Remember, your numerator or the number on top is the thing inside your division sign. The divisor, or the 20, is the denominator. It's what's going outside. So I should know right here, 20 cannot go into 4 5 different times. I should also know that's not the case, because if that was the case, this would have been an improper fraction. I should already know, since this is not a mixed number, 4 over 20 is a number that's going to be less than 1. So let's go ahead and start off. We have 20 goes into 4. Well, that can't happen, but I do know there's a decimal point here that wasn't there, that we don't really see. And I know that after that, there's going to be a placeholder. 20 can go into 40, or what looks to be 40 here. It goes in 2 times. 2 times 20 equals 40. And when I subtract, I get 0. Since I don't have a remainder, I can go ahead and say that that is the answer to my problem, but only if I remember to pop that decimal straight up. Now, if this was not a 0, I would continue to add zeros and bring them down until I did not have a remainder left, and I would have a longer decimal. That is going to happen on a few of these down here. Just letting you know. All right, to change, that's already part 1. 2 minutes in and we're basically done. The next part's actually even easier, if you can believe that. We're turning decimals into fractions, and it's only like a 2-step thing. A lot of times it's only 1 step. So you're going to write the decimal as a fraction. We did this the other day when we talked about turning our decimals into percentages. And when we did that, the numerator was the decimal, which is going to be the same as it was here. However, we're not going to do, we're going to put this means without the decimal point. So we're not going to put the decimal point in it. The denominator will be the place value of the last digit. So basically, when we're talking about turning a fraction into a decimal, we're going to ignore where the decimal point's at. So we're going to go ahead and write 48, because that's my numerator. And then my denominator will be the place value of the last digit. So the 8 is in the hundredths place. So we're going to make a 100 in the bottom. And we're not going to put our decimal in there. And look at that. I already have a fraction. Now I bet you can guess the last step. Simplify if you can, which means you need to know the GCF. So if I come over here, I got 48. I can do 12 times 4, 2 times 2. Those are both prime. 4 times 3, 2 times 2. So I end up with 2 times 2 times 2 times 2 times 3. Times another, no, that's it, right? 1, 2, 3, 4, yeah. And then for 100, let's do 5 times 20. 4 times 5. 2 times 2. 2 times 2 times 5 times 5. I'm not spending a ton of time on this because you already have notes on it. If I go through and circle my common pairs, I have 2's and 2's, nothing else in common. So my GCF is going to be 2 times 2, or 4. So I'm going to divide both my numerator and my denominator by 4. 48 divided by 4 is going to give me 12. 100 divided by 4 is going to give me 25. I'm going to box that up because it's my answer, and over here I should have boxed this up as well. All right, good luck, guys.